Hello and welcome to another set of 10 questions from the 10 a day series. Today I'm going to cover 10 questions from time, speed and distance. Now some of these questions are fairly easy and you should be able to get them. Some of the questions look difficult but are fairly easy if you apply logic to it, and some of them are indeed on the difficult side. Now if you enjoy my teaching and you are able to identify with what I do and how I do it, then there are a couple of programs for you. You can try out either the mastery programs if you are at the advanced stage of a preparation, or you can try out the power prep programs if you are starting from the very basics. On that note, let's start with the first question. So what we will do is I will show you a question. You can pause the video, try that question out on your own, and then have a look at the solution that's going to follow. Let's look at this nice question on trains and motorbikes. So have a look at the question, try it out. So there is a train that is of 300 meters and it is traveling at the speed of 45 kilometers per hour. It passes this point A completely. When I say point A completely, it means if this is point A, the train would look something like this. It would have just about crossed point A. So this is basically the train that we have, and we know that the length of this train is 300 meters. At the same time, a motorbike starts from point A. So let's say there is a motorbike that is starting here from point A. So this is what it might look like, right? So it is starting here from point A and it's traveling in the same direction as that of the train. Now when it exactly reaches the middle point of the train, meaning that currently the distance between the midpoint of the train and the position of the motorbike is half the length of the train, that is 150 meters. So now 150 meters have to be traveled. So distance has to be traveled at a certain speed, and then we'll be able to figure out the amount of time for which the motorbike would have been in motion. So what exactly is the speed that we have here? It is the relative speed, because both of them are traveling in the same direction. We will take the difference between the two speeds. The train is traveling at the speed of 45 kilometers per hour. The motorbike is traveling at the speed of 70 kilometers per hour. The difference between the speeds is 25 kilometers per hour. But 150 is in terms of meters, 25 is in terms of kilometers. The options are also in terms of kilometers. So what we will do is we will convert this 150 to kilometers. Now we know that 1 meter is, or 1 kilometer is 1000 meters. So that is what we will know. So that means that we will know that 1 meter is nothing but 1 by 1000 of a kilometer. So that is what it looks like. So we will divide it by 1000. So we'll just write it like this. So this is the amount of time in hours for which this entire combination would have been in motion, which means that the train and the bike, both of them would have been in the motion for this amount of time. We know that 25 into 6 is 150. Let's keep this 6 as it is. Now this is the amount of time for which the bike has been traveling. But the bike has been traveling at for this amount of time at the speed of 70 kilometers per hour. So we will be able to say that the amount of time for which the bike is covering the first half of this particular distance is going to be 42 by 100 or 0.42. That is what is going to happen here. What about the second part? Now in the second part, what is happening is, again, the distance that needs to be traveled is 150 meters, which means 150 divided by 1000 kilometers. But this distance is now being traveled at a speed of 65 minus 60. Because the speed of the train increases, the speed of the motorbike decreases, but of course the motorbike has to be faster than the train so as to be able to cover this distance. So now the relative speed is going to be 5 kilometers per hour. And then we will be able to get this. We know that 0.42 is the amount of, so basically this is the speed multiplied by the amount of time is going to give me the distance in kilometers. So same thing we will be able to do here. So 150 is the amount of, is the distance that needs to be covered. This is basically the speed. We are going to get the amount of time that is there, and if we multiply this by the speed at which this motorbike is traveling, that is 65, we should be able to get the distance in the second case as well. So we will be able to see that this is 5 into 13, that is 65. So I already know that this is 0.42. I can just cancel this out. If I get 13 into 15 divided by 100, I should be fine. Now 15 into 10 is 150 plus 15 into 345 is going to give me 195 divided by 100, which is going to give me 1.95 kilometers. So in the first case, the motorbike had traveled 0.42 kilometers. In the second case, it had traveled 1.95 kilometers. In total, if you look at it, 2.37 kilometers would be the distance that would have been traveled by the motorbike to pass the train completely. So that's a very manageable question. There is a lot of calculation involved, but if you just understand what exactly is given here, you should be able to get the answer. Let's look at the next question now. Two persons A and B are standing diametrically opposite on a circular track with a radius of 3.5 units. So again, have a look at this, try this, and then have a look at the solution. So let's draw the circular track. Let's say A is present here, diametrically opposite B is present. Now we know that the radius is 3.5. We know that the circumference of a circular track is going to be 2 pi r, or if you do 2 into 22 by 7 into 3.5, we will see that 2 into 3.5 is 7. So this is basically the circumference. 22 units is the circumference of this entire track that exists. Now they start running in opposite directions. Let's say A runs in the clockwise direction, B runs in the anti-clockwise direction, and their speeds are 4 units per minute and 7 units per minute respectively. So this speed of A is 4 units per minute and the speed of B is 7 units per minute. That is what we know here. On meeting each other, they take a rest for half a minute and then start running with twice the original speed. In 5 minutes, how many times will they take rest together? That is the question. So let's start here. Let's start with this question. If you are solving this, first of all, we know that because the entire track is 22, in the first case, we are only looking at half a track. Now, if you are looking at half a track, what is the amount of time for which this motion would have been happening? 11 units have to be covered at a relative speed of 4 plus 7. Because what is happening here is they are traveling in the opposite directions. Relative speed will, the concept of relative speed will tell you that these two speeds have to be added. So 11 divided by 11 will be 1 minute. So this is basically the amount of travel that is happening in the first instance. Then there is a rest time. Rest time is of 0.5 minutes. Then what happens? Now both of them would be somewhere here, right? So A and B are both here. Now both of them again start traveling in the direction that they were traveling earlier. So A will again continue in the clockwise direction, B will continue in the anti-clockwise direction. But the problem is that their speeds will be now twice of their original speeds, which means that A will now continue at a speed of 8 units per minute and B will now continue at a speed of 14 units per minute, which basically means that if the speed becomes twice of what it was earlier, for the amount of distance that is there, the speed should become half of it, right? So that it doesn't really matter. The amount of time taken should become half of the original time taken. But in this case, let's see what happens. So 14 and 8 is 22, and cumulatively they will have to cover 22 units. 22 units so as to be able to meet. So we will know that the travel time in the second case again is going to be 1 minute. So we will know that 22 units have to be covered in 1 minute. Then we have a resting phase of half a minute. So that is also fine. Then we again have a phase wherein they will be traveling. But now what will happen is, instead of taking 1 minute, they will now take half a minute. Why? Because I explained earlier, the speeds will become twice, the distance covered is the same, so the time taken will become half. If speed becomes twice, the time taken will become half in this case. So here the amount of time taken will be half of 1 minute, which is 0.5 minutes. Then again there is a resting phase and 0.5 minutes are up because 30 seconds is half a minute. Now let's see how much time has passed since the motion started. So 1 plus 0.5 is 1.5, plus 1 is 2.5, plus 0.5 is 3, 3.5 and 4. So we are now at 4 minutes. But what will happen the next time they are traveling? It will be half of this because the speed again becomes double. So we are going to have a travel time of 0.25 minutes followed by a rest time of 0.5 minutes. So now we are done with 4.75 minutes. So 4 minutes and 45 seconds. 3/4 of a minute is done. Now the next travel time is going to happen for 0.125 minutes because half of 0.25 is going to be 0.125, which basically means that it would have been 4.875 minutes. So 4 minutes and some change, right? 4 minutes and 52.5 seconds, I believe. That is going to be the amount of time that would have passed. And then again, they would rest for half a minute. Now, if they are resting for half a minute now, at this point in time, it will definitely go beyond 5. So how many times will they take rest together? This is the first time they are taking rest together. This is the second time, third time, fourth time, and fifth time. So they will take rest together exactly 5 times in the first 5 minutes. The given options are 6, 7, and 10. So the answer here is option D, that is none of these. So it takes some courage to mark option D or none of these as the answer. You will want to double check and see if you have missed something in this particular question, and that will take some extra time. But rest assured, if you have done the process properly, you need not recheck and you can just move on to the next question. So have a look at it, try this. It's a very interesting question, and then we will discuss this. And if you want a spoiler, then I'll just tell you, you will be surprised with the solution. So let's see. There are 2 riders on the horseback with a gun and a bulletproof shield. They were moving towards each other at a constant speed of 20 kilometers per hour and 5 kilometers per hour respectively, right? So there is a horse here and there is a person sitting on top of the horse that we have, and this person is moving here at say 20 kilometers per hour, and we have one more atrociously drawn horse that we have here, and there is another person who is moving at a slower speed of 5 kilometers per hour. So that is the speed at which these two horses and of course people on top of them are moving towards each other. They are 100 kilometers apart. So that is what we know here. They start firing bullets at each other at the speed of 10 kilometers per hour. When a bullet of rider 1 hits the shield of rider 2, rider 2 fires a bullet and the process continues vice versa. Neglecting the time lag at the instant when the bullet hits the shield and the rider fires the shot, find the total distance covered by all the bullets shot by both the riders. Now this is a very interesting question. Why? Because if you look at this particular question, what is happening here is you will have the bullets in motion throughout the entire journey. Now you just have to understand for how long is this journey happening, and you just have to figure out what is the speed of the bullet. We know that the speed of the bullet is 10 kilometers per hour. So if I know that these people have been firing bullets for 2 hours, I know that the bullet would have traveled for 20 kilometers. As simple as that. Now we know that they start firing bullets when they are 100 kilometers apart, and they stop firing bullets when both of them meet each other. That is the whole point, right? So in this particular case, we know that these 100 kilometers have to be traveled at a relative speed of 20 plus 5, that is 25 kilometers per hour, which means that bullets would be fired for 4 hours straight. So rider 1 will fire a bullet, it reaches rider 2, then rider 2 will fire a bullet, it will reach rider 1, then rider 1 will again fire a bullet, and this will continue. So in this particular case, for 4 hours, one bullet is in motion. That is what we can say. And we know that the speed of a bullet is 10 kilometers per hour. So in 4 hours, the bullet would have, or all the bullets cumulatively would have covered 40 kilometers worth of distance. So we don't need to find out how much distance is the first bullet covering, second bullet covering, and so on and so forth. We can simply see that there is one bullet that is going to be in motion for 4 hours. And because the speed of the bullet is 10 kilometers per hour, our answer basically becomes 40 kilometers. Let's move on to the next question. This is again a very interesting question, slightly difficult, you might think about it. So try this out and then have a look at the solution. Now, a group of soldiers are marching with a speed of 5 meters per second. So they are marching with a speed of 5 meters per second. So let's say this is the group of soldiers. Of course, you are not expected to draw this during the test, but let's say this is the group of soldiers. They are marching at a speed of 5 meters per second. If the distance between the first and the last row of soldiers is 100 meters. So this is basically the length of the unit or the group that is marching, which is 100 meters. A dog starts running from the last row and moves towards the first row. So there is a dog that starts running from the last row and moves towards the first row. Then when it reaches the first row, it turns and goes back to the last row. Now the dog has traveled 400 meters rather. What is the speed of the dog? Now you have to understand one very simple thing. The distance between the first and the last row of soldiers is 100 meters. So let's say, for example, the speed of the dog is some d, doesn't matter. Now what is happening here is the dog has to cover 100 meters or has to gain 100 meters when it is reaching the starting point. So what will happen in this particular case? The dog will take how much amount of time? The dog will take the dog will have to cover 100 meters, and this will happen at a speed of what? Both of them are traveling in the same direction. The dog will have to be faster than the group of soldiers. So d minus 5 will be the relative speed. This is the amount of time for which the dog is traveling in the forward direction. What about the dog traveling in the opposite direction towards the back? Then what will happen? Again, the dog has to cover 100 meters relatively if you are speaking. But in this case, because both of them are moving in the opposite direction, their speeds will get added. So the platoon or the group of soldiers will keep moving forward, and the dog will of course keep moving backward, which means that both of them will facilitate the meeting point of the dog with the back of this entire group. So in this particular case, we are going to get 100 upon d plus 5. Now this is the total amount of time for which this motion is happening. Now what do we know here? We know that the total distance traveled is 400, and we know that the speed of the dog is s. So what we can do here is, what is speed? Speed is distance upon time. This is the amount of time that is that the dog is in motion for. This is the distance that is there, and this is the speed. So with the help of this equation, we'll be able to get this. So if we shuffle the terms, we are going to get 4 into d plus 5 into d minus 5, which is d square minus 25. That will be the numerator. And d plus 5 plus d minus 5 is going to be 2d here. And this is going to be equal to s. So d, which is the speed of the dog. So this is what is going to happen. So if I just unscramble this, 4d square will be equal to, I could have cancelled a 2, but 4d square minus 100 will be equal to 2d square. That's what we are going to get. Or in other words, I'm going to get 2d square equals 100, d square equals 50, and that's why the value of d will be square root of 50, which is root of 25 into 2, or 5 times root 2. So the correct answer here is option A, 5 root 2 meters per second. Now have a look at this question. Again, it's a very interesting question, and if you are able to do this, great. You will be very happy about it. So let's see if you are able to get this. A train approaches a tunnel PQ which is 16 meters long. So approaching, which means that it has not really entered this particular tunnel. So let's say this is the tunnel we are talking about, and this is the tunnel PQ that we have here, and this is the train that we have, right? The train has a lamp as well, let's say. And the tunnel is 16 meters long. Two rabbits A and B are standing at points which are 12 meters and 8 meters inside the tunnel with respect to the entrance P. So entrance P, if you start from here, let's say entrance P, we'll just mark the tunnel like this. Let's say this is the entrance P, this is Q. Now if you start from here, there is one rabbit A that is at a point which is 12 meters away. So A will be somewhere here, and the gap between P and A will be 12 meters. What else do we know? There is a rabbit B as well, which is 8 meters away from P, which basically means that it will be at the midpoint of P and Q. So I'll just write B here, and I will say that, okay, this distance is 8 meters now. Now what is happening? When the train is X meters away from P, so if this distance is X meters, A starts running towards P and B starts running towards Q. So A will start running in this direction and B will start running in this direction. Now what is going to happen? Difference between the ratios of the speed of A to that of the train. So speed of A to speed of train, and the ratio difference nikalna hai. So SA by ST minus SB by ST is going to be 1 by 8. So that is what we know here. How much can the distance X be if both of them get caught at the ends of the tunnel? Get caught ka matlab kya hai? If the rabbit A is moving towards P, then rabbit A gets caught at point P, and if B is moving towards Q, rabbit B is going to get caught at point Q. So that is what, caught by the train, that is what it means. So let's see what we can do with this. So in this particular case, we know that SA by ST minus SB by ST is 1 by 8. But we know one small thing. When the train is here and the rabbit is here, let's say A, and both of them are traveling towards P. So what is happening here? When the train covers, or in the amount of time that the train covers X, rabbit A would have covered 12 meters. So can we say that the time remaining constant, we can say that the distance covered by the train divided by distance covered by A is going to be nothing but speed of the train divided by speed of A. If we reverse this, we will be getting the same thing. We'll get distance covered by A upon distance of train will be nothing but speed of A divided by speed of the train. But in this case, what is dA by dt? What is distance covered by A? We know that A would have covered 12 meters. What is the distance covered by T, the train? It is going to be X meters. So I know that the first part of this equation is going to be 12 by X. What about the second part? Now we know that B is traveling from here to here, which means that B is traveling 8 meters. So again, we can say the same thing. Distance traveled by B upon distance traveled by the train is going to be nothing but speed of B upon speed of the train. So what is the distance covered by B? As we saw, it is 8 meters because B is going from this point till the point Q that is there. So 8 meters. What about the train? The train is covering X plus 16. So we will say that the train would have covered X plus 16 meters. So 12 by X is the first part. And if you look at the second part, if you look at the ratios of the speed of A to that of the train and the ratio of speed of B to that of the train, so 8 upon X plus 16 is what we have. So in this case, if you look at it, the numerator is reducing, the denominator is increasing, which means that this will be a smaller fraction. So we are going to get minus 8 upon X plus 16 equals 1 by 8. Now I have one equation, one variable. You can do one small thing. You can just cross multiply and see what you're getting. You will get a nice quadratic. Okay, not really a nice quadratic, but you will get a quadratic. But instead of doing that, you can look at the options, plug in the values and see if you're getting something. Now 30 meters is the first option. 12 by 30 is going to give you 0.4, which is going to be greater than 0.125, which is fine, 1 by 8. But 8 upon 46 is going to be a weird value. So this is not my answer. What about 16? 12 by 16 is going to give me 0.75, which is fine. But 16 plus 16 is 32. 8 by 32 is going to be 0.25. I'm going to get the difference as 0.5, which is definitely not going to be equal to 1 by 8 because 1 by 8 is 0.125. So this is not my answer. What about 48? 12 by 48 is 1 by 4, which is 0.25, and 8 by 48 plus 16, which is going to be equal to 8 by 64, or 1 by 8, which is 0.125. The difference between these two is going to be 0.125, which is also equal to 1 by 8. So this is our answer. You could have also kind of factorized this and then tried to answer this question, but it would have been slightly painful. Let's see if we are able to understand something here. So 12 into x plus 16 will give me 12x, plus 12 into 16 if you do, you are going to get 192. 120 plus 72, 192. Minus 8x is what you are going to get. You have to multiply this by 8 as well. This is going to be equal to x square plus 16x. Now what will happen here? You will have 12x minus 8x, that is 4x, into 8, that is 32x. 16x minus 32x is going to give me x square minus 16x minus 8 into 192. So 8 into 192. We'll just write it as it is. Now if you are slightly keen in terms of figuring this out, you might be able to see that, okay, 192 is 4 into 48, which means 32 and 48 could be the two terms that are there. Because the negative, because the sum of the two parts is going to be negative, we will be able to say that x minus 48 into x plus 32 is going to give us the required result. This should be equal to 0. So x is equal to either 48 or minus 32. Now x cannot be equal to minus 32, because that will mean that the train is on the other side. So that is not acceptable. So what we will say here is x should be equal to 48 meters, which is also our answer. So option C is the correct answer to this question. Let's look at this question. Now try this question out and then tell me what do you think is the answer to this question in the comments as well. So Pranesh wants to travel to Pune. He has three options. Route 1, travel by a train from Chiprun to Mumbai, and then from Mumbai to Pune. The trains take 4.5 hours and 3 hours respectively, which basically means that the total amount of time taken should be 7.5 hours. Route 2, travel by a bus via Bhor. The distance covered by this route is 300 kilometers at 40 kilometers per hour, which basically means 7.5 hours, and there is half an hour break in between. So 7.5 hours plus 0.5 hours is going to be 8 hours worth of travel by route 2. And route 3, travel by a bus via Koina. The distance covered by this route is 500 kilometers at 60 kilometers per hour. Now 500 kilometers at 60 kilometers per hour will be 500 divided by 60, or you can say 25 divided by 3, which is going to be some 8.33 hours. You have to figure out which route should he take to save his time, which means that he should take the least amount of time. Now we can say that route 1 obviously is the shortest, but there is also a small point here which some of you might have missed. If Pranesh goes by train, there is a time span of 30 minutes between the respective trains, which means that there is going to be another half an hour that needs to be considered here, which means route 1 can be done in 8 hours, route 2 can be done in 8 hours, route 3 will take 8.33 hours. So which are the best routes? Route 1 or route 2, either of them is going to be equally fine. So in this case, the correct answer is option D, that is 1 or 2. Let's look at this question. This is a very interesting one. So have a look at this, try this out on your own, and then have a look at the solution. Now, the numbers expressing in meters the length of a fast and slow train, right? So there is a fast train that is there, there is a slow train that is there, and we know that the numbers expressing in meters. So in meters, if you are looking at it, it is are 3 times the numbers expressing in kilometers per hour the speed of the slow and the fast train respectively. So let's say I am talking about the slow train here, I am talking about the fast train here. Let's say the speeds of these trains are s kilometer per hour and f kilometer per hour. These are the speeds, let's say. Now what can we say about the lengths of these trains? So if I'm talking about the lengths of this, or length of the slow train, it is going to be 3 times the numbers expressing in kilometers per hour. So I'll be able to say that the length is 3s meters. The length here is 3f meters. That's what I will be able to say. Now the speed of the slow train and that of the fast train consists of the same 2 digits but in a reverse order. So slow train will have the same 2 digits and fast train also have the same 2 digits, but they will be opposite of each other. So instead of s kilometers per hour and f kilometers per hour, we can have a different variable so that our life becomes slightly easier. Slow train will have the speed of 10x plus y kilometers per hour, let's say, which means that the length of the train is going to be 10x plus y times 3 meters. That is what is going to happen. What about the fast train? The speed is going to be 10y plus x kilometers per hour. And what can you say about the length of this particular train? It will be nothing but 3 into 10y plus x meters. So this is what it will look like. Now, the time taken by the two trains to pass each other when traveling in opposite direction on parallel lines will be what? So, if they are traveling in parallel lines in an opposite direction and they have to cross each other completely, pass each other completely, which means that the total distance covered will be the sum of the lengths of the two trains. So, 3s plus 3f, or in this case, this is what we are looking at. 3 into 10x plus y plus 10y plus x, which will be 3 into 11x plus 11y. This will be the distance covered by the train. Distance divided by speed is going to give us the time. What is the sum of the speeds of these two trains because they are traveling in an opposite direction? In the opposite direction, what is going to be the relative speed here? It's going to be sum of the two speeds that we have. So 10x plus y and 10y plus x is going to be 11x plus 11y. This is what we are going to get. Now the problem here is this is in terms of meters and this is in terms of kilometers per hour. So what will you do in this case? Kilometers per hour will need to be converted to meters per second. So we will multiply it by 5 by 18. So what is going to happen? These two are going to get cancelled. I am going to get 18 into 3 divided by 5. This is what is going to happen. So we are going to get 54 divided by 5 or 10.8 seconds as the answer. So the correct answer here is going to be option A for this particular question. The amount of time taken for these two trains to pass each other is going to be 10.8 seconds. Now try looking at this particular question. It's a very simple, straightforward question, but it has escalators as well. So Michael Johnson is a great sprinter. He can climb 12 stairs of a staircase in 3 seconds. So the speed of Michael Johnson here is 4 stairs per second. But after climbing 480 stairs, his speed reduces to 8 stairs in 3 seconds. So 8 stairs in 3 seconds is 2.67 stairs per second. The Empire State Building in New York or NY has 90 floors and the lift takes 4 seconds per floor. So 4 steps or 4 seconds per floor is what we're talking about. To get to the next floor, one has to climb 12 stairs, right? So 12 stairs are being covered by the lift in 4 seconds, which means that what is the speed of the lift? So the speed of the lift is going to be nothing but 12 stairs divided by 4 seconds per floor, which is going to be 3 stairs per second. Something like this we'll get, right? So 4 seconds per floor, and we know that 12 stairs are there to be traveling from one floor to the next floor. So this is what we know, and otherwise we should be able to handle this nicely. So the lift is taking 4 seconds per floor for 12 stairs each, and Michael Johnson can climb 4 stairs in 3 seconds. So the speed of Michael Johnson is greater than the speed of the lift, but to a certain extent, because in the second case, the speed of Michael Johnson is less than the speed of the lift. So what will happen? Till the time Michael Johnson can climb at the speed of 4 stairs per second, Michael Johnson should climb the floors manually, and after that Michael Johnson should take a lift. Now 480 stairs are there, and we know every floor has 12 stairs, 480 stairs are there, and every floor has 12 stairs. There will be 40 stairs that Michael Johnson will be able to sprint at a faster speed compared to the lift, but after that Michael Johnson will have to take the lift to reach the top. So the answer should be he will climb the 40 stairs by himself, and then the remaining 50 stairs he will climb using the lift. So by lift is not going to be the optimum way, because the fastest way involves him being able to run for the first 480 stairs. Running again is not going to help, because after 480 stairs Michael Johnson will slow down by a lot. Run till 50th floor and then take the lift? Not really. He has to run till the 40th floor and then take the lift. So the correct answer here is going to be option D, that is none of these. Again, have a look at this question. This has got something to do with efficiency. So try this out and then have a look at the solution. A car goes 15 miles on a gallon of gas when it is driven at 50 miles per hour. So there is some correlation that exists. 1 gallon of gas makes a car travel for 15 miles at a speed of 50 miles per hour. When the car is driven at 60 miles per hour, it only goes 80% as far. So 80% as far of 15 means 80% of 15 or 12 miles. So when the car is driven at a speed of 60 miles per hour, what will happen is it would have traveled 12 miles per gallon. That is the whole idea here. Now, if the car is again traveling at 60 miles per hour and it has to travel 120 miles, how many gallons of gas will it take? Very easy. Now, 60 miles per hour, 1 gallon gives me 12 miles, but I need 120 miles. So, how many gallons worth of fuel will I need? And the speed remains the same. How many gallons worth of fuel will I need? 120 miles divided by 12 miles per gallon. That will give me 10 gallons. as my answer. So the correct answer here is option D, that is 10. Have a look at this question. Again, it's a very nice, interesting question. So try this and then we can have a look at the solution. Rakesh and Siddharth row on a river simultaneously from the same point. Rakesh rows downstream and Siddharth rows upstream in a way. So let's say, for example, same point is where Rakesh and Siddharth are. Now Rakesh rows downstream. So we can also say that, let's say the stream is also flowing in the same direction as Rakesh. And Siddharth rows upstream. So Siddharth is present here. Siddharth is rowing upstream. In 15 minutes, they are 2.25 kilometers apart. Now think about this, it's very interesting. Now if Rakesh is traveling with the stream, Rakesh would have covered, let's say, this much of distance in 15 minutes. Siddharth would have traveled this much of distance in, say, 15 minutes. Now we know that the distance between these 2 points is 2.25 kilometers, and that has happened in 15 minutes. So what can we say is the sum of the speeds of these two people? Why am I saying sum of the speeds? Because speed equals distance upon time, or speed equals distance upon time, which basically means that if I know the time, if I know the distance, I will be able to find the speed as well. So in this particular case, the speed which is going to be the relative speed. What is the speed of Rakesh and stream? If you think about it, the speed of Rakesh and the stream, let's say speed of Rakesh is A, speed of Siddharth is B, and speed of stream is S, let's say, for example. Now at what speed would Rakesh be traveling? Rakesh should be traveling at speed A plus S. What about Siddharth? Siddharth will be traveling at a speed of B minus S, because B is in one direction, S is in another direction. Siddharth will have to go against the stream. So the speed of Siddharth will be B minus S. This is basically the amount of, this is the speed that at which this motion is happening. And because both of them are traveling in the opposite directions, the relative speed will be A plus S plus B minus S. Now this is what we know. Right, so this is the relative speed, but speed is nothing but distance upon time. We know that the distance is 2.25 kilometers. We know that the time is 15 minutes. Now 15 minutes is 1/4 of an hour. So what can we say is the sum of the two speeds? Because S will get cancelled out. We will see that A plus B is going to be equal to 2.25 into 4, or 4.5 into 2, that is going to be equal to 9. So the sum of the speeds of Siddharth and Rakesh will become 9 according to the first case. Then what happens? Rakesh then turns to follow Siddharth, and after 30 minutes, right? After 30 minutes from the beginning, the boats have rowed together 3.5 kilometers. From the beginning, they have rowed 3.5 kilometers. So what happens here is, now Rakesh will start from, Rakesh will be here itself, and Rakesh turns to follow Siddharth. So Siddharth is already present here. Now Rakesh starts going towards Siddharth. That is the whole idea. And of course, at some point in time, Siddharth would have reached here. So I'll just put S dash here, and R would have reached some point here. We don't know where. So we'll put R dash here. But the idea here is that together they would have rowed 3.5 kilometers from the very beginning, but 2.25 kilometers happened in the first instance. So what is the extra distance that has been traveled from the first meeting point till the end of the question? It is going to be 1.25 kilometers. Now 1.25 kilometers would have been traveled at what speed? That is again important. Now in this particular case, S is traveling in this direction. The speed of, relative speed of S with respect to the stream is going to be, because they are traveling in opposite directions, it's going to be S minus B, as we had seen earlier. B minus S, as we had seen earlier. So B minus S is the speed of Siddharth. What about Rakesh? The speed of Rakesh is going to be again against the stream. So it is going to be A minus S. So this is what we are going to get in this particular context. Now you have to understand one thing, both of them are traveling in the same direction now. So if both of them are traveling in the same direction, then we are basically looking at the difference between the speeds, because both of them are traveling in the same direction, but we are looking at the amount of distance covered together, right? So 1.25 kilometers has been covered, 1.25 kilometers has been covered together, which basically means that B minus S would have been in motion for some amount of time, A minus S would have been in motion for some amount of time, and together they would have covered 1.25 kilometers. What is distance? Distance is speed multiplied by time. So in this particular case, B minus S is the speed of the system that involves Siddharth, but both of them have been traveling for 15 minutes, because 30 minutes from the beginning, 15 minutes from the, or after the first instance when we had calculated the distances. So this would be happening for 1/4 of an hour, this would be happening for 1/4 of an hour, and together the distance covered will be 1.25 kilometers. So we are going to get A plus B minus 2S, A plus B minus 2S is going to be equal to into 4 into 1.25 or 2.5 into 2 or 5. I know that the value of a plus b is 9. So we can say 9 minus 2s equals 5. Or we can say 2s equals 4 or s equals 2. That is what we are looking at. So at how many kilometers per hour does this stream flow? The answer here should be 2 kilometers per hour. That is the speed at which the stream should be flowing in this particular question.